In this video in section 13.3, we are going to finish your unit circle cheat sheet. So if you want to take that out and find that particular copy that we started in the prior video where we did radians and degrees, now we're going to finish it and we're going to put the trig values on it. Now in order to understand how this works, I want you to consider any point P that is on the unit circle. So there's point P right here. I'm just going to choose that random point. It could be anywhere on the circle, and I'm going to connect it to the center. Now, when I connect it to the center, that blue line is the radius. Again, this is the unit circle. This is the x-axis. This is the y-axis, which means this point is the point 1, 0, and this point right here is the point 0, 1, which gives us a radius equal to 1. Now, what I'm going to do is I'm going to drop down from point P. I'm going to drop down this dotted green line, which is going to make a right angle with the x-axis. Okay. And the coordinate of point P is the point x, y. This distance is x from here to the green line, and this distance right there is y. All right. So let's talk about the tangent, or let's talk about the trig functions. First of all, let's talk about sine. Our reference angle is the angle between the blue line, which is our terminal side of our angle, and the x-axis. So there's theta. Now we all know that sine, I'm going to write this in blue, we all know sine of theta is opposite over hypotenuse, which is equal to the opposite side is y and the hypotenuse is 1. Now, if I was to simplify that, we don't need to write over 1. Sine theta is equal to y. Very important to know, y and sine theta are always the same thing. Okay, so make sure you write that down, put a box around it. Let's talk about cosine of angle theta. Cosine, we know, is adjacent over hypotenuse. And so therefore the adjacent side is x over the hypotenuse, which is 1. Therefore, the cosine of theta, we don't need to write over 1, is equal to x. So our x-coordinate is always the cosine of theta, and the y-coordinate is always the sine of theta. So therefore, that is the coordinate of point P. Cosine theta is the x value, and sine theta is the y value. Very, very important. What I've written in the boxes, please make sure you highlight. Things that I have the red star by. Last, tangent of theta. Tangent of theta is opposite over adjacent, which is y over x. But y is the sine of theta, and x is the cosine of theta. So tangent of theta is equal to sine divided by cosine. Highlight that and put that in your notes. That is the value of the 3 trig functions based on the unit circle. So, with that information in mind, let's fill in your unit circle. Here's what we started the other day. Radians are in blue. Radians are in blue. I'm sorry, degrees is in blue. Sorry, degrees. Degrees is in blue. And radians is in red. Now what we're going to do today is we're going to put the value of the cosine, or the x value, is going to be black, and the sine value, or y, will be in green. So we're going to color code this. All right, so now let's use what we just did on the prior slide to figure these out. Don't write in point P, please. I'm going to use this as demonstration because I can erase. Let's say my terminal side is at 0. Okay, if my terminal side is at 0, that means point P has the coordinate 1, 0. All right, so now, if I ask you, our reference angle is 0 degrees, so if I ask you what is the cosine of 0, cosine of 0 would be the x-coordinate, which is 1. You can fill that in. Comma. The sine of 0 degrees is the y value from our prior slide. So therefore, sine of 0 degrees would be 0. Okay? That you can fill in. I'm going to erase all the rest. We're going to fill in the numbers around the outside. Now, let's say our terminal side went to 90 degrees. Let's say our terminal side went to here. So here's point P right here. Point P has coordinate 0, 1. Okay? So therefore, what is the cosine of 90 degrees? The cosine of 90 degrees is the x value, which would be 0. And the sine of 90 degrees would be the y value, which is 1. Okay, so therefore, I'm going to erase all of this. Now you can fill this in. The cosine of 90 degrees is 1. And the sine of 90 degrees, is 0. 0. Cosine of 90 degrees is 0. And the sine of 90 degrees is the value 1. What I'm filling in on the outside is the only thing that I want you to fill in. Now, following the same pattern, point P, let's say point P is over here at 180 degrees. Obviously, this coordinate is negative 1 for the cosine of 180, and it'd be 0 for the sine of 180. Okay, again, my color coding matches my key up here in the upper right corner. And finally, the very bottom, let's say point P was down here at 270. The value of that is 0 for the cosine and negative 1 for the sine. All right, so therefore we have now done our multiples of 90 degrees. That's what I want you to fill in. Now I'm going to draw in my x and y axis again like I had up here just a second ago. All right, now let's talk about 45 degrees. Let's say point P is right there at 45 degrees. Well, I'm going to draw my blue terminal line. Erase that a little bit, sorry. My blue line connects to point P. Remember, we're on the unit circle, so that's got a radius of 1. And I'm going to drop down my dotted green line to the x-axis. Well, what do I have? Well, theta, or my reference angle, is 45 degrees. Okay, so this is a 45, 45, 90 triangle, which makes the green side the distance 1 over the square root of 2, which is equal to the square root of 2 over 2. And it makes my black line distance on the bottom the same, since it's a 45, 45, 90 triangle. So therefore, the coordinate of point P, my red dot, is the square root of 2 over 2. That's the cosine value. And the sine value is also the square root of 2 over 2. All right, very good. So that takes care of that guy. Now, this whole chart follows patterns. So let's talk about quadrants. If this is the coordinate plane and the x and y axis, this is quadrant 1. We all know the signs up here are positive, positive, which matches our two numbers right there. In quadrant 2, the signs are going to be negative, positive. In quadrant 3, the signs are going to be negative, negative. And in quadrant 4, the signs are going to be positive, negative. Now, why did I cover that? Well, if I choose point P to be at 135 degrees, there's point P right there. And if I connect my point P to the origin, remember we use the reference angles to evaluate the trig function. So I drop down my green dotted line, and here is my reference angle, which is 45 degrees. Again, I have a 45, 45, 90 triangle. The radius of my blue line is equal to 1. So how long is my green line? Well, again, that would be 1 over the square root of 2, which is the same as square root of 2 over 2. And how long is my black line? My black line is also square root of 2 over 2. But since we're dealing with coordinates, this has a negative sign. because it's negative square root of 2 over 2 to get over here, and then positive square root of 2 over 2 to get up there. So that would be the coordinate of point P. The cosine of 135 degrees, I'm going to erase all of this. The cosine of 135 degrees is negative square root of 2 over 2, and the sine is positive square root of 2 over 2. And that's how you fill out all the 45-degree angles. So now, if I go down to 225 degrees, the cosine of 225 is negative square root of 2 over 2, because you're going in the negative x direction to get to point P, which is going to be right here. And then also negative square root of 2 over 2, because you're going in the negative y direction. And finally, 315 degrees will have positive negative. So the cosine of 315 degrees will be positive square root of 2 over 2. And the sine will be negative square root of 2 over 2. There you go. That's how you fill in the 45s. All right, now let's talk about the 30s. I'm going to do this very quickly and very briefly. If you got questions, please ask. So let's say point P is at 30 degrees. I'm going to draw my blue line, which is my radius of my circle. That's got a value of 1. And then I'm going to drop down my green line to the x-axis, so I have a 90-degree angle. And what type of triangle do I have? Well, my reference angle, which is right here, is 30 degrees. This is a 30, 60, 90. So using properties of 30, 60, 90, how long is my green line? The shortest side is actually half of the radius, or the longest side, which is a half. How long would the black side be? Well, if you know the shortest side, you times by the square root of 3. So the black side is going to be square root of 3 over 2. And there's your coordinate of point P. I'm going to erase point P. The cosine of 30 degrees is the x value. Cosine is the x value. That would be square root of 3 over 2. Sine is the y value, which would be a half, or 0.5. There you go. Now, all angles, or all parts, all angles that have 30-degree reference angles are going to be exactly the same. So 210, 150, and finally over here at 330, these will all have the same values, except the signs are going to change. So for instance, 150 will be negative the square root of 3 over 2 for the cosine, and will be 1/2 for the sine. So keep the numbers in the same order when you fill in 210 and 330. Last, let's talk about the 60 degrees. Okay, I'm going to erase all this. Now, let's say point P is up here at 60. If point P is at 60, our radius connects right there. Big blue line, the radius is 1. I'm going to drop down my vertical green line. Now our reference angle is 60 degrees right in here. So we have a 30, 60, 90. But the shortest side is now down at the bottom. The shortest side is right here, which is now a half. And the green line is now the square root of 3 over 2. So now for the angles that have 60-degree reference angles, the values have now changed. The cosine value is a half, and the sine value is now square root of 3 over 2. All right, so these numbers will stay in the order for 120, for 240, for 300. And that's how you do this. Now, if you have questions, let me know. I want you to jump ahead a slide because I have all the values filled in. And again, make sure black is cosine. Make sure your x value is cosine. Make sure your second value, your y value, is green or sine. And here it is. And if you need to pause the video, please do. But this is what your chart looks like. And I have underlined in green all the values for all the important angles on our unit circle. That's how they've been developed. That's where they come from. If you have questions, make sure you ask me in class. But please copy this chart exactly as